All right. Okay, how are you guys doing? I'm flourishing, thank you. I'm flourishing. Yes. Yeah. So, welcome everybody. So, yeah, as we mentioned yesterday, we're now done with regression. So we're now moving into learning unit 5. Sorry, yes. So we're now moving into learning unit 5, and learning unit 5, as we have, as we highlighted again also yesterday, is based on basic probability. Basic probability. So yeah, just trying to get this connect. Yes, I think we should be good to go now. So these are your learning outcomes. Okay, I'm not going to go through them, seeing that we've already lost some time. But yeah, we're basically just looking at the key fundamental concepts to probability. Okay. So first things first, what is probability? All right. Probability provides the foundation for quantifying and measuring uncertainty. Okay, that's the whole focus here. It says it is used to estimate the reliability in making inferences. Okay, we did learn that we do use statistics in order to infer from our sample population, right? So that we can then say to ourselves, okay, all of the relevant VCs, does the same criteria apply to them or not? Okay, so we also are using it for that, as well as quantifying the uncertainty of future events. Okay, when we're talking about probability, we are looking at what is the chance that something will happen, or the likelihood that something will occur. All right, examples of probability type questions. Okay, what is the likelihood that a task will be completed within 45 minutes? Okay, we obviously need to look at past data, and then based on that past data, how long does it take a student to complete a test 1 paper? I don't know the chapter in the book. Chapter 4. Thank you very much. All right. So we look at past data, and then we assess from there. We see, okay, 3 out of 5 students managed to finish their exam within an hour. So there's a 60% chance that you won't complete it within 45 minutes, for example. Next question that you would get there of a probability type question is, how likely is it that a product will fail within its guaranteed period? Okay. And then lastly, what is the chance of a telesales consultant making a sale on a call? Okay. That would also be looking at your closing rate. How many people do you need to call in order to close one sale? All right. Probabilities are broadly of 2 types, subjective and objective. Okay. Now I'm sure we're familiar with the concept of something being subjective and something being objective. So when we say subjective, it's based on my opinion. It's based on what I think, okay? Here they speak on an expert opinion, okay? So as a lecturer, what's my opinion when it comes to students who pass or fail in relation to attendance, all right? I assume that about 60% or about 80%, should I say, of students who attend will pass, okay? But if I want to be objective about that analysis, what needs to happen? I need to actually pull out records and say, so-and-so, so-and-so, so-and-so was actually in attendance. Did they pass? Okay, so when it comes to objective probability, all right, or objective statistics, we are talking about facts. They've been verified. Okay, they're supported by data. It's not about an opinion. This is what it is in a nutshell. Okay, then here, mathematically, a probability is defined as a ratio of two numbers. Okay, so there when we say P and then brackets A, we're saying the probability of A is equals to R, and R, if we check there, what does it represent or what is it? It's the number of outcomes of event A, okay, divided by the total number of possible outcomes, which is N. Remember, N, when we're looking at the units that we've been doing so far, N was the total number of variables or the total number of outcomes. Okay, so you can see that is being carried through here as well. So then here on this slide, they now give us an example. Okay, and here they say, assume that 350 Ford car owners were randomly selected and asked the following question. When you buy your next car, will you buy another Ford product? Okay, and they are looking at that as event A. Okay, now the answer obviously is either yes or a no. And here they're telling us that 76 respondents answered yes. So if we want to find the probability of loyal customers, we would then obviously say, okay, how many actually said yes? Because if they said yes, then obviously that means they are going to purchase or likely to purchase a Ford, which then obviously means that they are loyal to the Ford brand. So we say 76 out of the total number of respondents that we interviewed. So there you can see the calculation, 76 divided by 355 respondents, then gives you a 0.214 decimal number. And then obviously, when it comes to probability, either communicated as a decimal or we communicate it as a percentage. I like for it to be communicated as a percentage. There's a, sorry, let me just read this. It says, there is a 21.4% chance that a current Ford owner will remain loyal to the Ford brand name and purchase another Ford on his or her next car purchase. Okay, so they're also now basically saying they've actually rounded downwards here, but 1 out of 5 Ford owners is brand loyal. Okay, so that's now information that we can extract based off of what we have managed to gather off of that probability. And then deriving objective probabilities. There are 3 ways in which objective probabilities can be derived. Okay, so you've got a priori. All right, this is when the outcomes are known in advance. Okay, so for instance, when we flip a coin, you know that the outcome can either be heads or it is tails. So we know the potential outcomes. But sometimes we don't know the potential outcomes. Much like this Ford instance, we don't know how many people are going to say yes, how many people are going to say no. All right, and that we refer to as empirical probabilities. And there you can see what we then do is we have to conduct surveys, for instance. There's different things that you can conduct, but obviously we need to do research. And remember yesterday, I think we were, I don't know if it's yesterday or maybe the day before, but we were talking about, for you guys, one of the key reasons why you have to do stats or be exposed to it at the very least is because of research. Okay, so yeah, that's your empirical. The value of R and N are not known in advance. Okay, and then mathematically, all right, so they will obviously be using mathematical formula to determine our objective probabilities. Okay, so here on this slide, they're then talking to the 5 basic properties, right, that apply to every probability. First and foremost, your probabilities will always lie between 0 and 1, okay? Another way to look at that is your probabilities will always add up to 100%. Remember we said we can communicate probabilities either as a percentage or as a decimal, okay? Then secondly, if an event A cannot occur, that means that that probability is equal to 0. So here you can see they've written P, or probability of A, is then equal to 0, okay? Right here, right. Then, next one is if a probability is certain of occurring, if it's definite, like for instance, Nathan is always going to be in class or always going to come to class, that probability is then equals to 1. It's certain, isn't it? Yeah. Then 4, the sum of probabilities of all events is equals to 1, okay? So when you look at the potential outcomes, all of those potential outcomes, when you add them, they must equal 1. And then the last one is here, complementary probabilities. So for instance, the example they give here, if there's a 7% chance that a part is defective, okay? If there's a 7% chance that this projector does not work, what is the probability that it does work? If there's a 7% chance it does not work, right? Whenever a lecturer comes in and wants to do their lecture, what is the probability that it is working when a lecturer steps in? There's a 93%, and that's what they're talking to over there, all right? If probability A is the probability of an event occurring, then the probability of A not occurring is defined by probability A 1 minus probability A, okay? Right, so that is your properties in relation to probability. So here now they're just talking to, they're giving an illustration. We've done a survey on 50 fuel customers, and they've asked them, what is your brand choice? Which garage do you like? Do you like BP, Caltex, or engine? So forth, okay? And they found that 13 out of the 50 said they like BP, and so on and so forth. And then they are obviously your percentages. So here now they just have some probability questions. The first one there, they say, what is the likelihood that a randomly selected motorist prefers engine? Okay, so this is fairly straightforward. Remember we said to calculate probability, we say the desired outcome divided by the number of potential outcomes. How you said 0, 0,12. How are you getting that? Yes, 6 divided by 50. Okay, she is basically just applying the formula that I was just telling you about. Does it make sense though? We're all together on this, okay? Next one, what is the chance that a randomly selected motorist does not prefer Shell? Okay, so here now you just check the percentages of all the other selected and then say, okay, there's your probability. Okay, and this is obviously assuming we don't have any other petrol brands outside of what we have in front of us. Okay, last one, what is the probability of finding a motorist who prefers either the BP, Caltex, engine, or Shell brand petrol? Either. Okay, so that is C. That is question C. So here you can see you then get the probability of each of those. Then it's also saying these 4 events represent the collectively exhaustive set of events for the variable petrol brand. It is called a sample space. Okay, so if we look at it, even just from a logical perspective, we're basically saying what is the probability that a customer is going to prefer one of these four. Okay, and then again, this is assuming we only have these four. All right, there's 100% chance that they're going to pick one of them. Does it make sense? Okay, so there, if you look, they said the probability is 1. Remember, I said probabilities it ranges between 0 and 1, or you can say all your probabilities are going to add up to 100%. And here we've seen, because we've gotten all of our available options, there's 100% likelihood that they will pick one of those 4. Okay, right. So these are your basic probability concepts, which we'll be talking, adding a little more meat to today. Okay. Again, like I always say, whenever we're discussing theory, we're just trying to get the gist of what is going on in this unit. What is it about? What do we need to know? What is key? The real work is when we do exercises together. So you've got the intersection of events. This is, you'll see what it is, the union of events, mutually exclusive events, collectively exclusive events, and then obviously your statistically independent events. So here now, yes. Yes. 22/50, yes.
Why did they use BP and QUAT6221?
So we have to go back to the question. What was the question with B? They said, what is the chance that a randomly selected motorist does not prefer Shell? Does not prefer Shell. And then they went and they said 22/50. 22/50 is what? Is those who prefer Shell. Ne? 22 is for Shell, isn't it? So we know that 44% are likely to select Shell. So what I believe they've done here is they've just minused it from the 1 and then gotten, okay, this is the likelihood that they pick one of the other 3.
Instead of doing the 3.
Exactly, instead of doing the 3 and adding each one together. Okay. Make sense? Okay. Right. So here they're just giving us a frequency count. Okay, we've seen this before with our grouped and ungrouped data. Okay, and here they give the example of you've got the JSC, you've got small companies, medium companies, large companies, and then you've got the sectors that these companies belong to. It's 170 companies. You've got mining, financial, service, and retail. Okay, right. So there you can see of the small companies, how many belong to retail, for example. Of the middle, how many belong to the financial sector. And then of the large, you can see how many belong to mining, okay? So that is your frequency table there. And then they just follow up with then using this to illustrate some of the concepts. So the intersection of 2 events, A and B, is the set of all outcomes that belong to both A and B, okay? So in other words, this middle section, because can you see, it belongs to A and it belongs to B at the same time, okay? The intersection, okay? And that is represented by what we have over here, that upside down U, okay? Right. So here they're saying, what is the probability that a randomly selected JSC company will be small and operate within the service sector? Okay, how do you then calculate that? They're saying it must both be a small company, 1, and then 2, it must be part of the service sector. Okay, so there they're saying A intersection B is the set of all small and operate in the service sector out of the 170 JSC companies, okay, surveyed in the image that we saw, okay? So to look at that, we go back to our table. They said small, ne? Small, and it must be service. So can you see how we're coming to that number over there? Okay? And then obviously that's 10. But we know there are 170 companies that we can select from, isn't? So as such, we know that the desired outcome, we want any one of those 10, not so? But potentially we could pick any one of 170 companies, okay? So 10 divided by 170, you're obviously then getting your probability of 0.0588, okay, which rounded off, you get 5.9%, okay? So that's how you deal with probabilities that obviously, if we're looking for a probability that intersects, so in other words, meet two conditions. Okay, it could go on. You could look for a probability that intersects more than just two variables, but that's all we're interested in. So now when talking to the union, we are actually saying both potential outcomes, all of A and B. So here you can even read, it says the union of two events, A and B, is the set of all outcomes that belong to either event, A or B or both. Okay, it is written as A, UB, and there, as we spoke earlier, they said either A or B or both. Okay, so there you can see how here we've colored the whole thing blue because we're looking at all of it. Can you see that? 100%. Okay. All right, and then there again, they're just showing you how you go about calculating that. Okay. So again, here they are looking at small companies. That's event A, and then looking at service companies. Okay. Now, if we quickly go back, small companies, right? We have 36 small companies. And then service companies, we have 24. Okay, right. So now just take note of that. So now, isn't we said, no, the wrong slide here. So we said the union isn't. So here you can see we said 36 plus 24, but why did we say minus 10? Why did we say minus 10 to get our probability? Isn't here they're saying 36 plus 24 minus 10 divided by 170 companies.
So,
yeah,
like minus that 10 because there's 50 different companies. We're like 36 and 24 is 60. So minus 10 give you that 50. Isn't that the reason?
But remember, union is everything that belongs to, isn't? And when we looked at the table, we said that, I can't remember which is which, but we said that I think A is your small companies. We said we had 36 small companies. And B, we said we had 24 that belong to the service sector. So when we add, we still get 60. Which is what you guys are saying the same thing, 100% right. We're minusing it because those 10 fall within there, all right? They are both part of your small companies and also part of the, what sector was that? Service sector, okay? So in order not to duplicate, right, we then have to deduct that 10. Does that make sense? Otherwise, we are counting the same thing twice, okay?
So, but it wouldn't always be like this. Like, we have to deduct it. sometimes it will be another number.
Yes, sometimes it will be another number based on the scenario given, but 100% yes. The principle is obviously anything that is found in both, we have to deduct, we have to minus. 100%. Good question. Okay. All right. And that's how we arrive at that there. Okay. So here I think they're just illustrating what I spoke to. Then they're going to the third concept, which is mutually exclusive events. Okay. Mutually exclusive, we are saying that we can't have both B and A happening. Earlier I gave the example of Nathan always coming to class. Right? He cannot be in class and not in class at the same time. Can you see that? That's a mutually exclusive event. Either he is here or he's not here. Does that make sense? Okay. So whenever you hear, whenever they say in the question, this is a mutually exclusive probability or outcome, then you know it's either or. Okay. It's either or. Okay. What is the probability of a randomly selected company being a small and a medium-sized company? Okay, if we so quickly take that in, being a small and a medium at the same time, right? If we go back to our table, we see that you can't be both small and medium. It's either you are small or you are medium. Does that make sense? So can you see, that's why we're saying that's a mutually exclusive event. Okay. Events A and B are mutually exclusive since a randomly selected company cannot be both small or and medium at the same time. Okay. So there you can see small intersection medium is equals to 0. Therefore, the joint event is nil. Okay, there's no intersection there. Okay, okay, it's just repeating what we said. Therefore, this is an impossible event. So if they asked you a question like this, literally ask this question, that means that the probability is 0 for this specific question. Okay. However, here they are saying at the bottom, events are non-mutually exclusive if they can occur together on a single trial of a random experiment. So in other words, non-mutually exclusive is the exact opposite. We're now saying these two events can happen, such like what we looked at earlier, where we said a company can be small and it can also be part of the service sector. That is something that can happen. All right. Right. Then here, collectively exhaustive events. Okay. So here, basically, all we're talking to is we're saying we have put together all the potential outcomes. Okay. So here, events are collectively exhaustive when the union of all possible events, outcomes, is equals to the sample size. Okay. So in other words, whatever the probability might be, maybe let's read the example that give us a nice illustration. It says, this means that a single trial of a random experiment, at least one of these events is certain to occur. What is the probability of selecting a small, medium, or large company? All right, we know that we only have small, medium, or large. We don't have extra large, like at McDonald's, isn't it? So we know that definitely we're going to select one of the 170 potential outcomes. So the probability of that, we basically say, what's the probability of us getting a small company? What's the probability of us getting a medium company? And the probability of a large. And when you add those probabilities together, you're obviously going to end up with 1. Okay? Just further re-emphasizing the point, the whole point. Okay, then we also have statistically independent events. Okay, and basically what we're talking today is we're basically saying the occurrence of A has no effect on B happening and vice versa. So the occurrence of of A happening is not affected by B, all right, and the other way around, all right. And so here they use an example of NetBank, and they say the probability that a female banker using their online platform is not affected by the number of male NetBank bankers using online. They're independent probabilities. They don't influence each other in any way, shape, or form. Okay. The terms statistically independent events and mutually exclusive events are often confused. Okay. The distinction between them is as follows. When two events are mutually exclusive, they cannot occur together. They can't happen. They cannot happen, all right, together. The two events are statistically independent. They can occur together, but they do not have an influence on each other. Okay, so the moment you think statistically independent, I would advise that you start thinking in terms of maybe your regression or correlation. Is there a relationship? Nope, there's no relationship between these two events happening. Okay, then mutually exclusive, there is a relationship because either this happens or that happens, but both cannot happen at the same time. Does that make sense? So by virtue of saying they are mutually exclusive, it means that there is some sort of relationship, because if that outcome happens, if you pass, then you can't fail at the same time. Does that make sense? If you fail, then you can't pass at the same time. It's one or the other. Okay. Right. Right. Then this is now where we are going. This is now where the focus is. We are obviously concentrating not on subjective probability. We're interested in objective. All right. And yeah, we spoke to what objective probabilities already is, but here they're just notifying that we have three types. We have marginal probabilities, we have joint probabilities, and we have conditional probabilities. Okay, so marginal probabilities is actually what we were playing around with, where we were saying, what is the probability that we select a large company? That's a single event occurring. What is the probability that we'll select a large company? Okay. A single event refers to the outcomes of only one random variable. All right. Then there's an example, petrol brand preferences in example 4.2, and the probabilities calculations are illustrations of marginal probabilities, because they relate to the outcomes of the single random variable only. Okay, okay. Right, I think that pretty much. Okay, so this I've already spoken to, the first one as a marginal probability example. If we select a large company. Second question here, what are they asking? What is the chance that a JSE listed mining company selected is randomly selected? Okay, we'll leave that alone. Okay, so here obviously, much like the large companies, we say, okay, what is the total mining companies that we have? It's 41, and then obviously over the total number of companies that we have, which is your 170. So this is the calculation for the first question. And here's your calculation that I'm speaking to now. Right, so there's a 24.1 probability or chance of happening. So I think those marginal, pretty straightforward. We're looking into the possibility or the chance or the likelihood of a single event happening. Joint probability, we're now saying, what is the probability that we have more than one thing happening? That's all that we're talking to here. Okay. Both event A and B will occur simultaneously on a single trial or random experiment. Okay. All right. And then they're also just highlighting in yellow that sometimes it can be more than just two events, okay? And here they're also highlighting in green, they're saying that it's the same as calculating the intersect between probability of A and probability of B, okay? Right, then here they say the cross tabulation table shows all the outcomes of two random variables simultaneously. It is used to find joint probabilities. So we were actually looking at joint probabilities whenever we would say, what is the probability of us finding a small and a service company? All right, we're looking for two outcomes happening at the same time. Okay. Yeah, so I don't want to dwell any more on that. Then we will talk to this one and then we'll take a break. Conditional probability. Okay, so conditional probability here, we're basically, if you look at that P probability of B happening, assuming that A has already occurred. That's how you interpret the P brackets and then that line in the middle B. What is the probability of B happening? Sorry, probability of event A occurring, given that it's actually the other way around. My apologies. The probability of event A occurring, given that B has already occurred. Okay. So there you can see you've got the upside down U again. Okay. That's the formula. So yeah, simply you just need to remember we're looking at there the probability of A occurring, assuming that A has already happened. And it has to be that, sorry, assuming that B has already happened. Assuming that B has already happened. Okay. So here now they're just giving an example. They're saying, what is the probability that a randomly selected company is a retail company given that it is a medium-sized company? So B, remember we said has already happened. So we are basically saying we would have selected a medium-sized company, right? That is then also a retail company, or that happens to be a retail company. So first, we have to select the medium-sized company. Okay, so how do we then calculate that? We then say, instead of, remember all this time, we would then go to the place where it's a medium-sized and retail, isn't it? And we'd say 13. And then we'd say, for it to be both of those, we'd say divided by 170. But in this case, we're saying first it must be a medium-sized company, and then we also want to determine that it's a retail company. What's the probability of that actually happening? What's the chances of that being the case? So when it comes to your conditional probability, we are saying you would then say 13 divided by 46, okay, which is the total of medium-sized companies. We don't go with the total potential outcomes or the total number of companies. Does that make sense? So again, we select where both, all right, but then we say divided by the conditional outcome happening. Okay, and then I think we'll park it at that for now. Here they're just trying to illustrate some marginal probabilities, joint probabilities, and then your conditional probabilities. But yeah, let's quickly take our 10-minute break. In fact, you can come back at 2. We're just going to do the slides today, and then we'll call it a day. We've covered more than what we have to cover. So, yeah.